Good morning, everybody. Myself, Acharya Vishvendra, and today I'm going to discuss a worksheet on cells. So here is a cell of EMF E, internal resistance capital R, and it is connected to an external resistance capital R, and current in the circuit is I. So the first question here is, what is R equivalent of the circuit? So as we can see from here that small r and capital R both are in series because same current flows in both. So R equivalent is gonna be small r plus capital R. Next question is current in the circuit. तो करंट यहाँ से हो जाएगा EMF by R equivalent. EMF E है, R equivalent small r plus capital R. So I will be capital E by small r plus capital R. नेक्स्ट यहाँ पे है वोल्टेज अक्रॉस कैपिटल आर. तो इसमें आप ओम्स लॉ लगा दीजिए, V इज इक्वल टू आई आर. आई का वैल्यू है E अपॉन स्मॉल आर प्लस कैपिटल आर. तो वोल्टेज अक्रॉस कैपिटल आर आएगा E कैपिटल आर बाई स्मॉल आर प्लस कैपिटल आर, यहाँ से निकाल सकते हैं. नेक्स्ट क्वेश्चन इज EMF ऑफ द सेल. तो EMF हमें पता ही है, कैपिटल E है. नेक्स्ट इज टर्मिनल वोल्टेज. तो टर्मिनल वोल्टेज होता है जो एक्सटर्नल रेजिस्टेंस के अक्रॉस आता है, तो ये ई आर अपॉन आर प्लस आर हो जाएगा. नेक्स्ट इज वोल्टेज ड्रॉप इनसाइड सेल. तो इनसाइड सेल का मतलब है जो इस इंटरनल रेजिस्टेंस के अक्रॉस होगा, वाई इंटू स्मॉल आर होगा. तो आई का वैल्यू डाल दीजिए ई अपॉन आर प्लस आर इंटू स्मॉल आर, दैट विल बी वोल्टेज ड्रॉप इनसाइड सेल. नेक्स्ट इज पावर गिवन टू कैपिटल आर. तो पावर अगर हम इस रेजिस्टेंस के अक्रॉस देखें तो पावर होता है आई स्क्वायर आर. आई का वैल्यू यहाँ सब्स्टिट्यूट कर दीजिए, तो ये एक्सप्रेशन आएगा ई स्क्वायर कैपिटल आर अपॉन आर प्लस आर होल स्क्वायर. नेक्स्ट है कुछ ग्राफिकल बेस्ड क्वेश्चंस हैं. द फर्स्ट वन इज वेरिएशन ऑफ वी आर वर्सेज स्मॉल आर. सो एज वी कैन सी दैट it's inversely related, so it will be a shifted rectangular hyperbola like this. Then we have VR versus capital R. So using the equation we can say that if capital R is 0, VR will be 0, and when R will tend to infinity, VR will tend to EMF of the cell. So it will be like this, and when capital R tends to infinity, it will tend to capital A. So its graph will be like this. Then we need to draw the graph between VR and E. So seeing the relation, now VR and E are directly related. So the graph will be a straight line over here as shown in the figure. Then is a graph between I and small r. So if we look for the relation between I and small r, they are also inversely related. So graph will be having a rectangular hyperbola. So it will be like this, I versus small r, yeah, because at I versus small r elements, I think here this point, it will go inside like that, it will touch it, and it will be equal to E by capital R. This will be the correct graph. There is a bit correction in that. Then I versus capital R graph, it will be at R, capital R is equals to 0, I will be equal to E by small r. So both of these graphs will intersect the I axis, so the correct graph will be like this. Then we have I versus E graph. So I versus E graph, as is evident from the relation, that will be a straight line as shown in the figure. Next question is that we are being given a circuit in which EMF of the cell is 10 volt, internal resistance is 1 ohm, and it is connected to external resistance of 2 ohm. The first question is we need to find EMF of the cell. So that is equal to 10 volt. It is quite evident from the diagram. Next is current in the circuit. So the equivalent resistance will be 3 ohm. So I will be 10 by 3 ampere, we can say. Then is voltage across 2 ohm. So in this diagram we can say that V is equals to IR. I here is 10 by 3, R is 2. So the voltage will be 20 by 3 volt. Then is voltage across 1 ohm, that will again be IR. After solving we have 10 by 3 volt. Then we have power across 2 ohm resistance, so that will be I square R. I is 10 by 3, so that will be 10 by 3 whole square into 2. So that will be simplified to 200 by 9 volt. So that will be power given to the 2 ohm resistor. In the next question, we have another cell of EMF 20 volt, internal resistance 2 ohm, and there are two external resistances of 4 ohm and 6 ohm respectively. Now the first question here is we need to find R equivalent. So all of these are in series. So the R equivalent will be 6 plus 4 plus 2, that will be 12 ohm. Then we need to find current in the circuit. So current will be V by R equivalent. So 20 by 12, that will be 5 by 3 ampere. Then we have voltage across 4 ohm resistance, so that will be IR, so 4 into I. So 4 into 5 by 3, that will be 20 by 3 volt. Then we have voltage across 6 ohm, that will be 6I. After solving, we have 10 volt. Then we have power given to 4 ohm resistor, that will be I square R. I is 5 by 3. After solution, we get 100 by 9. And at last we have resistance in 6 ohm, that will be I square into 6. After solution, we have 50 by 3 as the power given to this. So you have seen that in a single video of 6 minutes duration, we have covered 24 questions. So these videos are made to optimize your time and energy. If you want to recheck your preparation, that are you capable to retain information when you solve a particular question, then you can use this video. And apart from studying, there is an important concept of retention of the information and patterns when you solve a question. And this retention process is very important and is the central part of preparing for competitive exams, because it involves use of the complete mind-brain system and especially the coordination of subconscious mind. So you can learn these things when you solve a number of questions based on the topic in which your entire mind-brain system is being checked. It's a testing of your memory, your creativity, your analysis, your visualization. In a short, these videos serves as a optimization tool for overall scanning of your mind-brain system, which is the central point behind cracking JEE NEET. So if you have any doubt, you can ask in the comment section. Thank you and have a nice day.